Hey folks, this is Dan Lattiser coming to you with Module 6, Interactive Advanced Concepts for Chem-125, Doane University's online program. And today we are doing the pasta rocket. So I have a little setup here. The items that you're going to need to conduct this are going to be the pasta glass container, some baker's yeast, hydrogen peroxide, the H2O2 lighter, and as you can see here, I have my glass container. It's going to be filled to about 3/4. I've drilled a hole in the top of this lid and placed it with my pasta, which is going to be the combustion reaction. So this will be lit on fire with the lighter right here. But the chemical reaction that we're looking at is actually going to be between hydrogen peroxide, which I have right here. I believe it should be at 3%, and some good old baker's yeast. And what you're going to be seeing here is baker's yeast is actually is a form of a microorganism. It's a eukaryotic single cell, and it produces a enzyme known as catalase, and catalase is, lo and behold, going to be the catalyst for the decomposition of hydrogen peroxide into 2 parts water, 1 part oxygen. So what we're going to be seeing is when this reaction occurs on top, the hydrogen peroxide and the yeast and the catalase degrading the hydrogen peroxide into the water and oxygen. It's going to be producing water that's going to be remaining within the container, and the O2, as it bubbles, is going to be forced out of this little hole in the pasta. And that oxygen that's being released is going to be a part of our combustion that's occurring with the pasta. As you know, that you need a source of flame. You need fuel, which the pasta is the fuel, and then our accelerant. You need oxygen, and the oxygen being the pure oxygen being put off is going to be the accelerant, which is going to increase and sustain. Should sustain a steady burn in this process. So let's go ahead and do it. What we're going to do here is place the about 3/4 hydrogen peroxide. It's about 3/4. Cap that up. Going to do the 1 packet of our baker's yeast, which is actually a decent amount of yeast if you consider the circumstances. Let's see here. I'll go ahead and stir this, kind of get this reaction going. Maybe too much yeast. So what you can see here is the bubbling that's occurring is definitely letting off a gas. I can't say that I can actually feel any oxygen seeping out, but that doesn't mean that it's not occurring. And we'll go ahead and see if we can get our desired reaction. There we go. Air rocket is in flight. That's actually working quite well. It's burning that thing off real quick. It's almost run out of fuel. It's hard to see with the camera and the lighting, but oh, there it goes. You can see that. You can see the oxygen flow coming up as it's as it was burning the pasta there. So that's pretty much it. Interesting thing, one of the reasons that this pure O2 works really well in comparison to air is that the typical air that we breathe is at about maybe 21%, 18 to 21% oxygen, and as this is reduced with the catalase, we get pure oxygen, which works as a much better accelerant in the combustion process. I don't think this is going to light because it's actually wet. I was going for round 2, but I think I'm getting it's actually just bubbling out of it now. That's a lot of yeast in there, so it's going to be, I think this process is going to be going for a while. So yeah, as I said, about 21% oxygen or O2 within our normal air, depending on your air quality. Another interesting thing, we have a little side-by-side comparison here, is your isopropyl rubbing alcohol and your hydrogen peroxide. The hydrogen peroxide, because it is because it's a I guess a kind of a it's temperate to quite a few different conditions. Your temperature and exposure to light and metals cause it to go into decomposition much quicker, which is the reasoning for the brown bottle. If you ever wondered why it's in a brown bottle, it's to reduce light, and it's also there's also traces of alkali metals that have been found in glass containers. So it's another reason why it's not in glass, is because it will keep longer in its form of H2O2 within the brown bottle in a nice cool storage environment. And that's kind of it. The experiment worked as we had hoped, and as well as the baker's yeast. That's another thing that's also contingent upon temperature, alkalinity or pH level. But under these two environments, it all worked very well. That's it for my video today, and I hope you guys enjoyed. Have a wonderful weekend. Thanks for watching again. You guys take care.